So we will look at a few more examples. So can you come up with an example of a stationary process? Forget about Gaussian, but stationary process. Any other examples?
Stationary processor we have just learned in the previous chapter, that is a Poisson stationary.
So what is? So can you describe the stochastic process there? What is the stochastic process? You should tell me x of t, t belonging to tau. Huh? Yes.
Or is it n of t?
Well, is n of t a stationary process? Can you say? See, n of t, t belonging to r. So n of t will give you the number of the count, right? The number of arrivals in 0 to t interval, right? So if I increase t, what will happen to expected value of n of t?
It will increase.
It will be lambda t, right? If you assume exponential. So if you assume Poisson arrival, it will be lambda t. So the mean will change with t. So that itself says that it's not stationary. Now what is stationary there?
Counting process.
Huh? That is the counting process, right? N of t is the counting process.
Inter-arrival times.
Inter-arrival times is IID, right? So why do you want to? You don't need any of these things. It's independent and identically distributed. That's the best thing that you can deal with. We can hope to see. In that case, for example, I take an unit interval, okay, some t plus 1, unit interval, okay. I will count the number of arrivals n of t in n of how do I call it? It's the number of particles or number of arrivals in time interval t to t plus 1, or in other words t to t plus tau, okay, in an interval of tau. So if you look at this process, is this stationary? Yes, right. It doesn't matter where you are looking at, it just matters what is the duration. Do you agree?
Yes.
Intuitively you can see that, right? It doesn't matter which day are you looking at, it just matters how long you are looking at that, right? The arrival is like it kind of forgets, and the number of arrivals will statistically speaking will remain the same as long as the duration is the same, right? So the stochastic process, if I call this as a stochastic process with width tau, right? If you fix tau, right, or I'll write it properly. No, let me not even write it as, I'll call this as t1 and this is t2. So this will be t1 comma t2. So you look at this t1 comma t2 as some the number of arrivals in this t1 comma t2, right? So this, if you shift it by, for example, tau, right, t1 plus tau, t2 plus tau, so the difference is t2 minus t2 t1. So the number of arrivals in this interval is same as, statistically same as the number of arrivals in this interval, right? How many what is the statistics here? What is the statistics? What can you say? Huh?
N of t2 minus t1. N of t1.
Is it n of t1? What is the statistic? So if we have an exponential inter-arrival time, okay, and independent across, if I take two intervals, right, so what will be, so suppose what will be the arrival here? Let me call n1. This is n2. So what can you say about n1 and n2 statistics wise? See, n1 is again the number of arrivals will be again Poisson with what is the rate? Lambda times t2 minus t1, right? Similarly, this is also Poisson with rate lambda times T2 plus tau minus T1 plus tau, which is T2 minus T1. It doesn't matter where you look at, it only depends on the duration, right? Do you agree? Well, is this correct? No. No. Sorry. This is not correct. So it should depend on tau. It should not depend on T2 minus T1, right? So the tau is the difference. So here, okay, this is also not a. What is the right description here? How do you say that this is stationary? So it should. So now it says it doesn't matter where you take. So as long as the width is same, the statistics will be the same. But now, yeah. So this also is stationary. Why? Because not only it doesn't even depend on tau, right? Independent of tau. So it's naturally. I mean, this is an example of a stationary process. Is that fine? Is that okay? I mean, did you get it? This is a simple stationary stochastic process because the definition says it should depend on the difference, right? U in this case, T and T plus 2, so it should depend on U. But whereas here, it doesn't even depend on the difference. It doesn't matter where you look at, it's the same. Is that fine? Yes or no? Yes or no? Any questions? Ayush?
No, sir. Here
Ah,
you have taken the difference. You are saying that it depends on the difference only, no, sir. That is
correct,
tau.
correct.
So, sir, please go to the screen, sir.
Hmm.
Yes, sir. Here T1 and T2, we have taken N1 is
Correct,
this, and N2 is saying this. If we
correct.
can this fix this tau, no, sir.
Ah,
So, every time, sir, if we take T1, T2, if this is a fix,
hmm.
then we always get at this point only, sir. No? If we add tau to this,
No,
so
you
sir,
add
it
any
will not
shift,
change
right?
only,
Now,
sir, because it will not change only, sir. It will shift to
exactly, exactly.
there.
So that is also in a stationary stochastic process, right? Because see, I'm saying this
Yeah,
depends on
but
the
sir,
difference. Yes,
this the NT you are taking the counting process, no, sir. Yeah.
yes. N1 is the yeah.
Yeah, so sir, if within this interval, so
Hmm.
suppose there n1 means suppose n number of people are coming. So after if we add this tau, then
Mhm.
how can we guarantee that here also it will only the n number of people will be there also?
No. It's not like that. So the number of people arriving could be different. It's random, right? What I'm saying is the statistics, the probability that n people will arrive in an interval of t1, t2 is same as the probability that n people will arrive in an interval of t1 plus tau and t2 plus tau.
Yes. That's interesting.
It's not the number, it's the statistics that won't change. In
Okay.
fact, the statistics won't change across, right? So it's more than stationary. It's kind of interesting. So, and if these two intervals don't overlap, one can show that n1 is independent of n2. These two random variables are independent because of independent increment property. Okay, one can show this. Maybe homework. Okay, show that n1 and n2 are independent. I want you to submit this. Okay, independent if, okay, so tau is greater than t2 minus t1. Okay, so this, okay, strictly greater than t2 minus t1. Okay, shall we move on?
Yes.
Okay.